Okay. Hi everyone. Welcome to the almost the last session of the day. This session is going to be about developing of applications for ESP32. So first I'm going to introduce ourselves. So my name is Ivan Grohardkov. I'm the Director of Software Platforms at Espressif, and Espressif is the company which is behind ESP32 chips. And this is Kondal. Kondal is working on the Eclipse plugin for ESP IDF, so for developing the applications for ESP32 chips. And he will, in the second half of the talk, show a demo and tell a bit more about the plugin. Yeah. So I'm going to start first with an introduction. So first of all, what are these chips and how they relate to IoT and what kind of environment we have for programming these chips. And later this will kind of move to the second part of the talk where we're going to talk about the Eclipse plugin. So first of all, a bit about the company. So the company it's about 10 years old. It's based in Shanghai, China. And we have offices also in India and Europe. The main thing that the company does is designing the MCUs. And those MCUs typically are used in kind of connectivity applications. So these MCUs integrate Wi-Fi or Bluetooth. And you can really easily add them into an existing product or into a new product to add connectivity. Aside from designing the MCUs, we also design modules around them. So modules typically make it easier to add these connectivity into some existing product, and also build software and libraries for these modules. So yeah, so starting off the basic thing, the chips themselves, the SoCs. We call them SoCs because they are relatively slightly more complicated in terms of their internal structure than a typical microcontroller. So aside from being a microcontroller, what is a microcontroller basically? It does have some CPU, it does have some memory, it does have some peripherals typically used to control or interact with the external devices. So SoCs, they also integrate other things. Like in our case, they integrate analog parts, so there is Wi-Fi radio or Bluetooth radio. There are some ADCs, DACs, and so on. So the chips themselves, we also manufacture modules which are based on the chips, and the modules, the primary purpose of the module is to provide what is called modular certification. So if you're integrating a Wi-Fi or Bluetooth device into your product, then the product must later pass FCC or CE or some other national certification that it doesn't cause some interference or causes not more interference that it is allowed to cause. And the modules, they kind of are a way to make it easier for for device manufacturers to pass this certification. So if we pass ourselves, we certify the module, then certifying the product is usually a lot easier than if we go just from bare SoC. On top of the modules, we have development boards. So development boards typically integrate the module and a bunch of other supporting circuitry which you may want to use to actually do some software development. There are different development boards. The one pictured here is the most basic one. It just has the module. It has a USB to UART converter. So UART is a serial interface used for interacting with these modules. And a couple of buttons. That's it. Can't get any simpler than that. There are more sophisticated boards, like for example, this one is a board which also has Ethernet connectivity. So it has the chip has Ethernet MAC and the board has the Ethernet PHY, and it also has PoE module. So this one can be used for some kind of gateway applications for both Wi-Fi and Ethernet connectivity, and some other boards as well. And finally, there are SDKs. So I will talk a bit more about what goes into an SDK a bit later. But essentially, these are all the libraries you need to start programming. Aside from the SDKs, we also are looking to make it even easier to build the full application by also looking at the cloud side. So quite soon we will announce some projects which will help you get started with the cloud side easier as well. So let's have a look at this ESP32. ESP32 is currently this is the latest chip we have released. It's actually been released in 2016. So this year we have one more chip coming out, and I'm going to talk about it a bit more. So what kind of characteristics we are talking about? So this is around 0.5 MB of internal memory, which is not a lot. So you can't run Linux there. Typically, we use something like FreeRTOS in such constrained environment. But it is at the same time sufficient to do things like TLS and HTTP or MQTT and some higher level protocols. The program itself is stored in external flash memory, so the flash memory is usually cheap enough, and we can attach like 4 MB or 8 or 16 MB of flash memory. Looking at just a comparison with some other chips that we have. So ESP8266 was the first chip that came out. ESP8266 was really well known in kind of maker, hacker community because it gave a really inexpensive way to add Wi-Fi to something. So basically for $2 to $3 you could put this module into whatever you want and it would make it Wi-Fi connected. So ESP32 was a later iteration on that. It was dual core. It is dual core. So actually one of the first dual core MCUs, and we had to develop FreeRTOS, like FreeRTOS port, which would support a multi-core. And ESP32S2 is a chip that is coming out this year. So probably we will have the first samples shipping before the new year. It basically improves upon ESP32 in security perspective. So we added more sophisticated security peripherals, like now we have AES, XTS, flash encryption and decryption. So because the flash is external to the chip, unlike many other MCUs, we can offer a protection of your code and data using AES, XTS. And also RSA, PSS, secure boot, and a lot of OTP storage. So ESP32S2, it doesn't have 2 cores and it doesn't have Bluetooth, but it is quite a step up in terms of security. So what kind of applications we are primarily targeting? So those are most of our customers. They will be in consumer electronics market. So things like appliances, air conditioners, washing machines, home floor sweeping robots, and so on. Toys, all kinds of Alexa-like devices, so smart assistants, Bluetooth speakers, and so on. And the chips are also finding their way into some of the industrial devices. So we have some bridges and gateways, mainly if there is some existing equipment that needs to be connected to wireless interfaces, then these chips add a relatively simple way to add this kind of connectivity. Data collection, some monitoring devices, and even into embedded controllers, although this is probably like we are not targeting some safety critical applications at the moment, but still some embedded controls are also being made based on these chips. So what do we use to program for these chips? The SDK for these chips, we call it ESP IDF, and it's open source. It's Apache 2.0 licensed. We develop this mostly internally, but we sync to GitHub usually every day or every couple of days, and we accept contributions. So we have quite a lot of contributors there. The SDK has some online documentation, so if you are interested in getting started with ESP32, then you can check it out. It includes getting started guides and all the things you need to follow to kind of go into the detail. So what does the SDK typically include? So I'm saying SoC vendors, like not specifically Espressif, but other semiconductor companies, they also provide similar solutions. So what actually goes into an SDK? The basics, the startup code, the bootloader, the linker script, so all the low-level stuff you need to actually compile and link a valid application for this target. Of course, we have that. Peripheral drivers, they are usually also vendor-specific. For some semiconductor vendors, it stops at this point. So we also provide RTOS. In our case, we use FreeRTOS, which is very well known to most everyone who works in embedded space and kind of been ported to lots of devices. It's a relatively simple RTOS, but its popularity makes up, I think, for some missing features. We have the network stack, cryptography, and TLS stacks. And on top of that, also all kinds of protocols like HTTP clients and servers, MQTT, CoAP, some libraries for cloud connection, like, for example, AWS, IoT SDK, Azure, Google IoT Core. So these are also available as libraries. And also some things that you typically don't find in vendor SDKs, like semiconductor vendor SDKs. We also provide quite a lot of POSIX abstraction. So you can use pthreads, even though this is FreeRTOS. We still provide pthread layer, which builds on top of FreeRTOS. So this way we, for example, can implement features like in C++ 11 threads. They're typically based on pthreads, so we can support that as well. And some other tools like profiling, tracing, and IDE, which is the topic of this talk. So the highlighted parts are basically parts which usually are very custom to different vendor SDKs. So there is less variability in file systems. There are only a few network stacks. There are only a few TLS stacks which you can run on microcontrollers. So different vendor SDKs typically are closer in these parts. But things like the choice of RTOS, the choice of build system, these is more complex. And I would like, for the purpose of this, like my remaining couple of minutes, to focus on the build systems. So what actually goes into the vendor SDK aside from the actual code? For C, there is no real standard for the build system, right? So you have lots of different build systems. And even for every build system, like make, CMake, and so on, you can develop project in a slightly different way, which will make it not entirely compatible with other projects developed on using the same build system. So in general, this is the problem of packaging. There is no well-defined packaging format for C projects. And although in desktop environments nowadays you would say that, okay, maybe CMake is that standard. So if you have a C++ project, you will probably have CMake build system around it. And if it's more than CMake, that it will be very easy to integrate. But in embedded space, there is a variety of different packaging formats like ARM. So ARM member companies, they typically use CMSIS. So CMSIS packs, it addresses this problem, but there are many solutions and they're not compatible. So basically everyone has to invent something of their own. And yeah, and other questions here as well, like how do you do compile time configuration? So how do you introduce some configurability to your code? CMake doesn't really answer this question. So you can define macros, but how do you expose those macros to the user? It's not entirely clear. And how do you integrate with IDEs? So for ESP IDF, we have this concept of components, which are essentially libraries. And at the moment, they're just CMake libraries with some extra sugar on top to make up for the missing features. And each component typically includes some source files. They can be source files written by the component author, or this can be some third-party library which is wrapped into a component. And it includes the CMake list file and also includes the kconfig file, so the same kconfig you see in Linux. So we use kconfig system for configuration. And then the build process looks like something like that. So the top part essentially is your normal C application you build with CMake. So you have sources, you feed the sources into CMake, and CMake generates a build script, which is Make Ninja or even Eclipse project. And that feeds into the build system, and then from the build system you can produce an ELF file, and ultimately this ELF file somehow gets loaded into your development board. And the bottom part is related to configuration, so we use kconfig, and we use a few tools which help us interact with kconfig. So there is a command line menu config. It's the same blue screen you have in Linux make menu config. And we also have something like called conf server, which is a server which knows all the logic of kconfig and interacts with the IDE which provides the presentation of this configuration menu. And also the other point where integrate with IDEs is CMake generates compile commands JSON for us, and compile commands JSON allows IDE language server to figure out, well, it allows IDE to figure out all the include paths for every source file and all the build flags. And this in turn allows the parser and the language server to properly parse the C code and find all the the types and identifiers and so on. So that's kind of the high-level view of the build system. And yeah, so if you want to get started with this, then what you will need is some, let's say, a development board. Typically, it's like this kind of board, a cable, and a few tools listed here. And so what we offer is also Eclipse Plugin. So I will pass to Kondal for the plugin part.
Yeah, thanks, Ivan.
I guess for the questions, if you have any questions about this part, we can also you can ask later when we're done.
Sure. Thanks, Ivan. Welcome once again, guys. So we started working on this project, developing the idea of Eclipse plugin like a couple of months now. It's been like 7 to 8 months. So main aim of this project is to simplify the things what we have in the Eclipse CDT, because if you look at the Eclipse CDT, it is having a provision to create your CMake project, and also you can flash it to your ESP32 device. The thing is, there are a lot of configuration things which we need to do. So, and also it doesn't provide all the capabilities what ESP IDF is offering. So we thought maybe we should have something, for our community, so that, because even today, Eclipse CDT is one of the favorite IDE for an embedded developers, for an IoT developers. We thought maybe we should have something for them. So with that, we started on this. So this is basically developed on the Eclipse CDT, I would say. So whatever the plugins which we developed, it's completely based on the Eclipse CDT stuff. So we already released the beta one. It's been like 2 weeks now. It's an open source, so it is available in the GitHub. So please take a look at it. So the main challenges we are trying to solve with this plugin is, as I mentioned, there are a lot of things which we need to do, like mainly the tool chain configuration. So we need to define the CMake tool chain, and also an IDF tool chain. So all those things which we need to configure, and also certain variables, the environment variables we need to configure at the Eclipse CDT side, because in general, Eclipse CDT is designed in such a way that it can work for any of the things. So what we are trying to do is to focus more on a ESP IDF boards. So, and also like since someone wanted to program the ESP32, there are certain tools which we need to run, and so those tools, as an user, they need to identify what version they need to pick it from the GitHub, and for each ESP IDF version, they need to identify, what is the supported version for that particular ESP IDF. So that's, a bit tedious for any user who wanted to start. So yeah, so with this we are trying to improve the onboarding experience with that, and also we support like end-to-end workflow. In the sense you start from the installing the tools to like flash the device, and you can do your debugging and all that stuff. And also you should be able to do even the menu configuration related stuff, where whatever you used to do, like if you wanted to do configuration for a project specific things or a board specific things, so everything you should be able to do it from the Eclipse now. And yeah, so we'll also support, since this project is from the Eclipse, from Espressif, so we'll be supporting if you're having any issues on that front. So these are the plugin features which we are offering. Like I'm going to demo all of them. So it's basically like installing all the ESP IDF tools like CMake, extensor toolchain, and the related the OpenOCD. So all of the related stuff. We are having a provision to create your CMake IDF project. So far that is something which is not available in the Eclipse so far, even if you are taking the standard Eclipse CDT. So this is possible only with our plugin now. And yeah, so we have to provision to create your launch target, because since we are also coming up with the S2 chip, ESP32 S2, so we should have a provision to configure whether ESP32 or S2 launch target. And we should be able to compile and flash the project to the board, and we have a provision to see the serial output as well. So apart from that, we are also having SDK Configuration Editor, where you can specify application related things. And we also integrated the CMake editor within this. So this basically provides, if you're working with the CMake, since it's a CMake build project, so you will have a lot of content assistant features, IDF specific properties and commands as part of that. And yeah, so we also auto configured all these things, like configuring the environment variables and tool chains. And for flashing in the project, you don't really need to do anything, but if you wanted to customize certain things, we can always have a provision to do that. And we also have some templates, like someone wanted to get started quickly, so we'll have certain templates for each area, like Bluetooth, Wi-Fi, for every area, so they can quickly get started with the project. Yeah, so we can able to import an existing projects. So we do support the JTAG debugging. For the GDB hardware, so basically we can do it in two ways. The GDB hardware debugging plugins is, anyway, it's coming, I think from the last 2 releases, it's coming along with the Eclipse CDT itself, so we need not to install anything. But someone wanted to debug with an OpenOCD, so they need to still get through an update side, and they can start doing it. So yeah, as you guys know, like if you want to do a debugging with the ESP32, so we need to have the JTAG adapter. So this is basically my the rover kit. So this is having the FTDI, the JTAG adapter. So with that, we should be able to debug your ESP application. So OpenOCD and these tools anyway will be installing as part of the through install process from Eclipse. So these are the prerequisites, I would say. So all we have is like Java, Python, and the Python is for an ESP IDF, because we are running certain commands from the Eclipse IDF tools, something like that. So we need a Python for that, and we need an ESP IDF because we don't currently at this point of time we don't have a provision to install ESP IDF from the Eclipse plugin. So maybe in the future, yeah, we will be working on that. But currently, so from the GitHub we need to clone and then need to provide the ESP IDF directly in the Eclipse. Okay, yeah, let's get into a demo. Probably that will help. Just delete the existing one. All right, so so if someone is starting with an Eclipse CDT, the first thing they need to do is make sure you are in the CDT perspective. So make sure that you select this and you are in the CDT perspective. And the next step should be since we have a provision to install the tools, so select the Espressif IDF Tools Manager and click on Install Tools. Okay, so what it does is it's basically try to look for the required IDF tools which are required for it. Since I already have my ESP IDF configured, so it is trying to install all of them. In the sense it's already downloaded. It just it is just making sure that we have it or not. So just verifying those things. But you can always verify. So these things will be installed as part of the .espressif folder. So all the tools will be installed as part of the .espressif. As you can see, so this is all the downloaded one, and this is what will be installed as part of it. And these are the tools which are basically required for this. Even if you delete this and install, it should work. So once you have this, you can start creating a project. So from the file new, so select the Espressif IDF project. Probably I wanted to run a Blink example. So you can do two things here. So either you can finish it right away. It will create a default ESP template project, or you will also have a provision to select from the available templates. For that, just tick the checkbox, and yeah. So there are sort of examples for each area, as I mentioned, like you can for an Ethernet, for the Bluetooth. So we have a lot of examples. Someone wanted to start on this. So I'll just go with the Blink. Fine, so the project got created. This is the default structure. To specifically identify whether it is ESP IDF project or not, so there is, so IDF nature got added. So if someone is interested, like basically if you go open the dot project, we'll be having IDF nature. So based upon this, we'll identify whether to use the IDF builder or the C builder. So a lot of people are facing, based upon our observation, like a couple of guys are facing this issue, so make sure we can check this. So this is my default the Blink example. It's basically, it will turn on and turn off my LCD screen because this is a rover kit. It's also having LCD screen. With some time delay, it will try to switch on and switch off the display. As you can see, there are a lot of errors here. It's because still we have not attached the tool chain for your project. Once we compile this project with a particular tool chain, all the errors will disappear. So make sure that you select the launch target here. If this launch target is not there, you can go and create your ESP launch target from here. And so since I already have, I'll just select your serial boot. Fine, then you just go ahead with the compilation of this project. So yeah, this will take a couple of seconds, I would say. So if you want to see what exactly is happening in this, you can just stop the scrolling here. You can just go up there. As you can see, we are trying to run the CMake Ninja build command from the build folder, and we are also passing the toolchain file. Yeah. So yeah, let's wait for the project to build. So you might wonder, like, from where we have configured the tool chain. So the tool chain is configured as part of the install tools process. If you have installed the tools from the Eclipse, all those things will be taken care. Everything is configured as part of the preferences. Just to verify, so a couple of things you can actually check here. The CMake. So here is the tool chain which is configured. And another one is the core build tool chains. You can verify these settings. If this is not configured earlier, probably due to some issue, so you can always add the new thing in the user defined tool chains. So other important thing here is to make sure that you have all the environment variables created. So these things, specifically user need not to do anything unless they have some issue, because it's all auto configured. So yeah, if you're having some issues, so please refer to the documentation. We have all the details for this. Fine, so this is compiled now. So yeah, we can just flash this to the device. So this will flash your application to your device. Yeah, so once the application got flashed, as you can see, this is started blinking, and yeah, so we can able to do debugging as well from this. So yeah, so if you wanted to see what's happening behind the scenes, like you wanted to see the serial monitor, so there is an option for that. This is the button. So this is a serial. This will open the terminal. So select the serial terminal from here, and make sure that you select the correct serial port, and just click OK. Yeah, that's it. All right, so this is about the flashing the application. So what I'd like to show other features which are part of this plugin is SDK config. As I mentioned, we should be able to do everything from the Eclipse. That's our aim. And yeah, so you can just click on this SDK config file. This will launch the configuration editor. And as you can see, like it supports everything, what you get in the menu config if you're trying to do it from the terminal. So you should be able to, change the settings, and yeah, it supports basically everything what you can. So the UI is also very dynamic. So the moment you click on this, as you can see, the underlying trees are added with respect to their options. So you should be able to do everything from the SDK configuration editor. So I'll just save this. And other thing is for the CMake list, as I mentioned, so we also install the CMake editor as part of this plugin. So you should be able to see all the content assist for this, and also the syntax highlighting, and also we'll be getting the IDF related properties and methods. So wherever is required, we should be able to use this. Yeah, probably I can show you like how we can do the debugging. For that, so basically if you want to do a debugging, so there is an option called, so go to the debug as, debug configurations, and here you will see the GDB Hardware Debugging. So yeah, for this you need not to install anything. So this, if you're having an Eclipse CDT and you got your plugins, you should be able to see this option. And just click on this. There's sort of configuration things which we need to do it here. So instead of you doing all these things, we have provided the launch configuration. We can just import it and you can start debug it. So for that, I have a few files for that. So what I'll do is I'll just import it. Let me see if I already imported. Okay, not there. All right, so let me import it. Go for launch configurations. Click next. So on the desktop, I have my config files. So these files is also available in the GitHub. So if you guys need it. So I'm importing these, the GDB Hardware Debugging and also OpenOCD Debugging related configuration files. So if you open this configuration file, as you can see, a couple of things which we need to verify here. So make sure you select the project and also your, the LF file. And under the debug section, make sure you select the GDB command if it is not detected. And yeah, the rest of the arguments which are already configured. So as you guys know, like the maximum debug points which you can set it on the hardware is only 2. So we need to set off, we need to define these arguments here. And we wanted to break our program at app_main. So this is what we defined here. Yeah, so we can ignore the rest of the things. So what I'll do now is I'll just go and put a debug point, maybe somewhere here. All right, so since this is a GDB hardware debugging, there are certain things which we need to do it from the command line, because in the sense like we cannot really start your GDB server from here. If you use the OpenOCD debugging, everything is from the Eclipse, but if you are using a GDB hardware debugging, so we need to start the command GDB server from the command line. Okay, all right. And I just need to so this is because of the collision with an FTDI driver and Apple driver. So we need to unload it before we start the debugging, and then probably you can go and start. This should work. So yeah, GDB started on this on the port like 3333, and yeah, it should now work. All right, so you can proceed with your debugging with this. All right, as you can see, so when I'm stopping on the particular breakpoint, it is switching off the light and switch on. Fine, that's about debugger. All right, I'll just kill it. It's the same for OpenOCD. If you're using an OpenOCD, you really need not to define, you need not to start anything from the command line. It's everything from the tool itself, because here itself we are starting the GDB server as well as the client, both the things. So yeah, okay, thanks everyone for joining the session. So if you have any questions, we'll be taking them.